Ever wonder if you could build a computer and its entire operating system completely from scratch, just like a tech wizard in a movie? Well, it's not just fiction. It's a real and fascinating world that enthusiasts dive into, using open source tools to create truly unique machines. Let's explore how someone, let's call them Zero, would pull this off in the near future. First up, the hardware. Forget buying off-the-shelf parts from big brands. To have total control, Zero would start with something like a Field Programmable Gate Array, or FPGA. Think of it as a blank microchip that you can program to become whatever you want. Instead of a proprietary Intel or AMD chip, they'd use an open-source CPU architecture like RISC-V. This means the very blueprint of the processor is open for anyone to see and modify. For a laptop, projects like the Framework Laptop or Alamix Series I are game changers. They provide open-source schematics and design files, so you can literally 3D print your own chassis or customize the internal boards. It's the ultimate DIY dream. But what about all that old junk? Old computers can be resurrected by replacing their locked-down proprietary BIOS with open-source firmware like Coreboot or LibraBoot. This strips out the mysterious black box code from manufacturers, giving you full control over the machine's most fundamental level. Now for the really ambitious part, creating the operating system. Building an OS from the ground up is a monumental task. It starts with writing a bootloader, a tiny piece of code in a language called assembly that tells the hardware how to wake up. Then comes the kernel, the heart of the OS that manages memory and CPU tasks, usually written in C or C++. It's like building the engine of a car before you even think about the seats. For a quicker, more modern approach, there are OS kits like Cosmos, which stands for C# Open Source Managed Operating System. This lets developers build a functional OS using a more familiar, high-level language like C#. But a more common method is to create a custom Linux distribution. You can take a bare-bones base like Arch Linux, strip away everything you don't need, and then build your own unique environment with only the software you choose. This way, you're not starting from absolute zero, but you still have complete control over the final product. Finally, to keep the entire system free from outside influence, all software has to be built from its original source code. This is where compilers like the GNU Compiler Collection, or GCC, come in. They act as translators, turning human-readable code into the machine language that your custom-built CPU can understand. Some developers even create their own programming languages, tailored specifically for their OS. A legendary example is Terry Davis, who created the language Holy C to build his unique operating system, Temple OS. The ultimate goal for a project like this is to become self-hosting. This means the computer and its OEs are stable and powerful enough to be used to write and compile their own next version. Imagine a computer that can build its own successor without needing any external help. It's a beautiful concept of digital self-sufficiency, turning junk and open source code into a fully independent, personalized computing universe. It's a huge challenge, but for those who value freedom and understanding in their technology, it's the ultimate adventure. Thanks for watching. If you found this fascinating, hit that like button and subscribe for more deep dives into the world of tech. See you next time.